I was going to discuss something else today, but it turns out that some students fell behind. They didn't understand. They didn't understand the arguments for plasma. Okay, and so what I did was I got some of their comments, and I'm going to be addressing some of their comments, as well as rehashing some of the arguments for plasma. Okay, so here was one comment person made. He said, so a snapshot of plasma is just gas then? Okay, because you have, these three states of matter, which are solids, liquids, and gases. Okay, and then there are some people, especially the electric universe folk, the thunderbolters, they claim that there's something called the fourth state of matter, and they call it plasma, and they say that, again, that's the fourth state. And so the question is, fellow says, if we take a snapshot of plasma, like, I work with plasma, and you could see it through some of these windows the machines have, so you could see, some of the sputtering in there, some of what was going on in there. What if I took a snapshot of that? Okay, or we send Atom Man, he goes in there and takes a snapshot of so-called plasma. What would we get? Well, for sure we wouldn't get plasma. And you say, well, hold it, you just took a picture of it, Bill. What do you mean you won't get plasma? Yeah, you won't get plasma, and the reason is that you have to look at language. And people forget about the language. They say, I just wanted to show that in physics we can take a snapshot of plasma. No, you cannot. Not in science. Maybe in everyday speech you can, but not in science. In science, plasma is defined as a process. You cannot take a snapshot of a process, of any kind of process. Okay? You take a snapshot of a machine that's running, and all you have is a picture of a machine. You don't have it running. And plasma is a machine that's running. You can take a picture of the machine, but not of its running. And plasma is the running part. It's a process of ionization, constant ionization. So when you take a picture of plasma, you have nothing. You don't have a gas. You do not have because a gas is just the atoms there without any ionization. You don't have a gas, you don't have liquid, and you don't have solid. What you have is whatever, invent the word for it. For sure it's not plasma, because plasma is defined as a process of ionization. That's why you haven't taken a picture of plasma. You take a picture of ionized gas, but we don't even know that, because all we see is assuming we take the quantum version, all we see is electrons here and protons or hydrogen atoms or whatever over there. That's all you see, okay? And what is that? Well, we have no word for that, okay? Okay, because plasma, again, is a process, a movie, okay? That's the problem. Okay, another fellow, he gave it his best shot. Says, if I take a picture of the chair, then of it burning, then of the ashes, what is it then? Okay, it's burnt wood. We could use some of that here in Germany. It's cold out here, burn some wood. And then he says, you are saying that state is an event. State of matter. My God, poor fellow. I think he got the scarecrow's brain. Poor fellow. Yeah, no, it's not an event. In fact, I argued exactly the opposite. What he was listening to, I have no idea. Okay, here's another fellow says, introducing movement into the state of matter is irrelevant. I guess his religion went down the drain, and so he's going to fight for plasma till the end of his life, and so will everybody who's been educated on the basis of plasma. They will never release plasma because their whole religion is over, That is their icon. That is their God. You can't take plasma away from them because they're dead, essentially. Okay, so what's the problem? Yeah, of course, there's no way they're going to get into the discussion whether the word state represents motion or the word state is a single frame in the universal movie. That's the whole issue. And if plasma is a state, it better be a single frame in the universal movie. And if it ain't, because it's a process, because it's an action of some kind of movement, it's a movie, then it can't be put into a single frame, and therefore it can't be a state, because that is what a state is, a single frame, okay? And in fact, this fellow, I think it was him, he goes in there and starts talking about motion. Liquids, gases, solids are states of matter, okay? When heated, immediately talks about heat, okay? The standard model recognizes hydrogen as being gas, but when heated. So the first thing everybody wants to do is move it around. They heat it. and do other fancy things that we'll find out in a minute here. I don't want to get ahead of myself, but yeah, there's immediately they're going to move it. They're going to do some motion. They're going to talk about motion, okay? Because you can't talk about plasma. You can't even get to plasma until you do some motion. And then plasma itself, you know, is not a cross section of time. It requires 2 frames of the movie because it is a process. Plasma embodies motion, which gas, liquid, and solid do not. That's the difference between them, okay? Okay, and here's gas. Okay, people think that gas is something that's moving. Well, is gas moving in that still image? I took a snapshot of gas, two examples. Is anything moving in those 2 snapshots, those 2 pictures, those 2 still images? So no, we do not need to have heat, gas, or do anything or see it moving in order to call it gas. I can see, in fact, I show that to anybody and I ask them, what would you put that under? Would you put that under solids, liquids, or gases? And probably just about everyone with a little bit of brain would say, well, that looks like a gas to me. But it's not moving. Yeah, but it still looks like a gas to me. It could be smoke. It could be vapor. It could be who knows what. But what you're staring at is a still image of a gas. That's what it is. That's not a solid. No one would confuse that for a solid or for a liquid. Everybody would say, well, it looks like gas. That's what they would say. I mean, straightforward, no runaround, okay? You don't need motion. Okay, so another fellow says, I think it was the same fellow, maybe, I don't know, but hot energetic surface of the sun is creating plasma. Hydrogen becomes plasma. Yeah, they start talking about creating and becomes, and reminded me of a movie, Death Becomes Her. These people don't understand the word becomes. Okay, and what it is they don't want to get involved in grammar. They say, look, I didn't come here to do grammar. I came here to do physics. But they don't realize that physics is 150% grammar. Science is 100% grammar. You better define your terms before you do physics. Okay, that's the problem. And some people say, Bill, you're inventing your own dictionary. You can't do that. It's exactly the opposite. It's exactly the opposite. In science, you must define your terms. You have to bring your personal dictionary. Let me repeat that because people say, oh, you got to use the dictionary everybody uses so we can follow you. It's the other way around. In order to follow me, I'm going to present you my definitions, the one that I'm going to use in my presentation, my dissertation, and I'm going to define those terms. If you don't like those terms, you can't say, well, that's not what it says in the dictionary. That's not what all the mathematicians at the math club voted for. That's not what I was taught in school. That's not what the authoritative, authorities out there say these words mean. None of that has anything to do with science. In science, you must define your own terms. If they're the terms, if you're going to use the terms that are out there, no problem. We can accept them at face value. But now comes, the criticism. Now you have to defend your definition. So if you're going to use a definition that you found in the Wikipedia or in the dictionary or in some kind of encyclopedia of sorts, no problem. Bring whatever word that you are going to use. You better know something about that word if it's a critical one that makes or breaks your theory, because we're going to try to destroy it if it's irrational. And you can't say, well, that's how we always used it. We don't care how it's always used. We don't use democracy. We don't vote for definitions, authority, none of that, or tradition. None of that is a valid argument, or that you can say the etymology began over here. We don't care. We don't care in science who created the word. In fact, all the words that were created by our forefathers hundreds of years ago are almost all wrong. Okay, they're all irrational. They cannot be used in science. In ordinary speech, you can use whatever you want, but in science, we are going to go after your words. So yes, please bring your personal dictionary. Those are the only ones that we will accept. We will not accept you using tradition and authority and saying, well, that's what I found in the dictionary. That's not an excuse. You should know better. Okay, so yeah, you have to define your own terms. Anyways, one fellow said today, says, PBS literally contradicted you the very next day. regarding plasma, whether it was the fourth state of matter, right? And so you have the PBS guy, Matt O'Dowd, there speaking about why plasma is the fourth state of matter. He was trying to justify it. Didn't do a good job at all. And so this fellow says, you don't believe temperature or pressure, even though you could have seen it yourself. Matt O'Dowd, the host, right, of this PBS, I think it's called Space Time program, he essentially said, plasma is created, becoming, death becomes her, through temperature and pressure. Okay, so you need these two actions, these two physical phenomena to create plasma, temperature and or pressure. Okay, so this is what this fellow brought up. Okay, so let's look at what Mr. O'Dowd had to say. Yeah, here he is. He says the following. He says, heat a block of ice and it melts into liquid water. Okay, so you have a block of ice, you heat it and it turns into water. Keep heating it until it boils into gas, right? And now you have water vapor. Okay, so you have these three states of matter. How did he accomplish them? Well, he did it through heating. But he says it's not just temperature that determines the state of matter. It is also pressure. Okay, pressure, what is pressure? Can you take a picture of pressure? A snapshot of pressure? Can you take a snapshot of heat? Of temperature? No, obviously not, because those are things in motion. In the case of temperature, what you have is vibrations, right? And what's vibrating is actually, heat is the vibration of the rope. What it is the torsion of many ropes at a higher frequency. That's all heat is under the rope model. And then pressure is just atoms against atoms. Okay, so there is motion there. You have compression. Okay, so he said he just did the same thing as everybody else. O'Dowd does not understand that plasma is not the fourth state, because state is a static image. And he's going to talk about pressure and heat, which he cannot synthesize in a single frame of the universal movie. Okay, so here we have my answer to him in a way, okay? Do we need to have pressure or do we need to have heat to talk about the category known as solids? A solid, okay? Here's the definition I found. Having three dimensions, length, width, and height, as a geometric body or figure. Okay, where was the motion? Where was the pressure? Where was the temperature? Is it in there anywhere? No, we don't need the word temperature or the word pressure to define the word solid. We say table, it belongs to solids. Why does it belong to solid? Because it's three-dimensional and geometric body or figure, which is not totally true, because solid can be, in the case of geometry, they had solids, which are cubes, ideal cubes, and they are not 3D in the sense that, like, you can put them out here, okay? But just keep that in mind. I can have a 3D visualization of a cube out there, and it doesn't have to be, it is 3D conceptually, okay? So that's all you need to be aware of. But anyways, having relative firmness, coherence of particles, and persistence of form, okay? So yeah, in fact, if you put pressure or heat, you may not end up with a solid, depending on how fast and how much. Okay? So yeah, for the definitions of the categories, solid, liquid, gas, you do not need temperature, pressure, or any of the things that Mr. Matt O'Dowd mentioned. Okay, give me a second here. Okay, here we have a fellow, and he gives us an idea what a state is. And so listen to him. I think he's put it out very well. He says the following. He says, a state does not include anything about its, the system's history. Okay, so you do not need a history of something to talk about a state. You do about plasma, you do about ionization, but you do not need about to have a history that underlies the word state. Okay? It says the path, how the point mass got from A to point B, is not a state. Correct. State is the condition of the system at a given time. Correct. Given time is a cross section of time. That's a given time. You freeze the universe. You cut the tape of the universe, the videotape, the universal movie, at one tape only, at one frame only. And there we have that at the bottom, okay? Ionization is an example. Process, history, okay? By which an atom or a molecule gains or loses, verbs, gains, loses, verbs. Electrons during chemical, what? Changes, verb, also verb. Change in physics is verb. Change is not a noun, okay? Yeah, ionization requires at least 2 frames of the movie. In this case, I showed 3, just to show that it loses an electron. Okay, that's the official version. And what is plasma? Plasma is ionization. Bunch of ionizations. That's all it is. A bunch of atoms doing what you're seeing there at the bottom. Okay, that's all it is. It's just, here's ionization is 1 atom. Plasma is many atoms doing ionization. And what is ionization? What does it say there? It's a process. What is plasma? It's a process. It's a phenomenon. There's something in motion. It's a running boy. It's a flying eagle. It's a swimming bird. It's a running, galloping horse, you know. It's all of those. That's what plasma, jumping kangaroo, like I like to say. Okay, so yeah, you look it up. You look up the definition of the word state. It says, state, a particular condition that someone or something is in, what? At a specific time. What does that mean? It means a single frame of the universal movie. There is no time in a single frame. It's the present, you could say. It's the present frozen. That's what a single frame or a specific time means. There is no interval of time. Okay? State is a static concept. Okay? State is conceptually a cross-section of time in the universal movie. There is no motion embodied in a state. There is motion embodied in both ionization and plasma. Therefore, they do not qualify as a state. Okay? Motion, 2 locations or more than 1 location of an object. Best way to memorize it: state equals static. Okay? Static. 1 frame of the universal movie. That's what a state is. Okay? So let's get that right. Okay, if you don't understand that, well, I can't help you any further. It means that you too probably got a little bit of the scarecrow's brain out there. Okay, this fellow continues and he gives us all kinds of examples of why plasma is not a state. Plasma contains what? Charged, something in motion, particles. Charge is a phenomenon, something in motion. These charged particles sets plasma apart from other states of matter. Exactly. Plasma is superheated. Okay, it's heated. Heated means motion. Electrons are what? Ripped away. Verb. Rip is a verb. Means you're taking something away from something. You cannot synthesize rip in a single frame of the universal movie. An ionized gas, again, ionize is a verb. Okay. Plasma glows. Glows is a verb. Motion. Examples of plasma include lightning. Lightning is electricity. It's something in motion. You cannot take a snapshot of lightning because what you took a picture of is really electricity flowing, and they call that image lightning. And people confuse the image, the still image, with what that bright ray represents, which is electricity. Excited gas, excited, verb. Solar wind, what is wind? Moving air, or in this case, moving, you know, whatever is out there. Welding arcs, an arc, again, electricity. Okay, so all these contain motion. Plasma is a form of matter in which many of the electrons, what? Wander. Wander, verb. It's motion, means it goes everywhere, wander around. The electrons in a solid, liquid, or gas stay with the same atomic nucleus, which is not what happens to the plasma. Just as a liquid will boil, changing into a gas, heating a gas will form a plasma. You must heat the gas. Okay, so plasma does have a history because the word plasma includes the history of heating. It is a process. You have to see before and after to conceptualize the word plasma for the purposes of physics. A soup of charged, what is charged? Motion, particles, ions, and negatively charged particles, electrons. So yeah, plasma is a thing in motion. And so you cannot isolate the motion or plasma from its motion, because the word embodies motion. It's part of the definition of the word plasma. So it's got to do with grammar, not with what you think plasma is. Oh, I took a picture of plasma. No, you did not take it. That's in ordinary speech. In science, you cannot take a picture of plasma because plasma is defined as motion. You cannot take a picture of motion. That's the issue, okay? You take a picture of the boy running, or you took a picture of a boy. That's all we see in the picture. We don't see him running. And the running part is the part that you cannot isolate from plasma. Okay, here's one fellow, and he says the following. He says that there are not only 4 states of matter, meaning plasma being the 4th. He said there's a 5, there's a 5th one. Okay, let's find out. There are 5 known phases. Phases? Phases doesn't sound like the same thing as a state. So phase and state do not compute. Phase is something that happens. State is something that is. So phase is not a state. But these people are not very particular about, grammar, and so they skip over these nuances, these little things, these details, okay, of matter, solids, liquids, gases, and he includes plasma, and he also includes something called Bose-Einstein condensates. What are these bozos? These boson condensates. What are these? It says the main difference in the structure of each state is in the densities of the particle. So he's saying the issue here is just density. Okay, so there we have a solid, and it's got all these atoms or molecules, whatever you want to see that as. Atoms is fine. So we have all these atoms close together, and they don't move, they don't vibrate, they don't flow, and we call that a solid. Okay, then we have liquid, they're farther apart. Okay, we don't have to see them moving. Again, liquid, you can see milk on the floor and say that's a liquid, no problem. Gas, same thing as a category. I just showed you that you can take a snapshot of gas. It doesn't have to be moving. We call that gas. Smoke, you take a picture of smoke, that's gas. Okay. But plasma, you have the ionization. You have to have the electrons coming out. So people say, well, what did you take a picture of there, Bill? Well, I don't know. We don't have a name for it because they call it plasma, like it says there, but that ain't plasma because I don't know what happened before. I need the history of what happened before in order to conceptualize the word plasma, okay? But he's got a Bose-Einstein condensate. What is that? Well, that's just all the atoms closer together. That's all it is. So it looks like a solid, this boso, okay? So all we have is this boso condensate. It's just another form of solid. It's a solid. It would fall under the category of solid. But let's make sure we, cover that base well. Here it is, okay? The boso condensate gas is cooled to low density, 100,000 times less dense than air. Okay, so all they did was freeze something, and they call that a boso condensate. Great. And what is that? Well, that's a solid. But then they clarify what this thing is, okay? And they say the state of the the Bose-Einstein condensate is described by a wave function. And there you see a wave function. But it doesn't look like it's standing still. It looks like it's moving. So if that's a Bose-Einstein condensate, and it's a wave function, and a wave function is something in motion because it's an equation. An equation only, always, ever represents something in motion. There is no equation that gives you any static. You get 1 point, but then you throw another variable in there, another one, or a constant or whatever. You change something in the equation to get a curve, which is motion. What you're putting is dots that show some kind of motion. All equations only represent motion, okay? And so, the wave equation is an equation of a wave, and there you see it in motion. So obviously, if that's what a condensate is, it looks like it ain't a solid either. It's simply a liquid. I don't know what to call it because, again, if it's a liquid, you got to be able to take a snapshot of it. And if it's a gas, you got to be able to take a snapshot of it. And here, I'm not sure I can take a snapshot of that because I would get, some image there, and I would know what that is. And that would not be a wave function. In order to be a wave function, I got to see it moving. Then it's a wave. Wave is always a verb. Okay, so not very good because now we don't know if this boso is a solid or a wave. Could be one of the two. Okay, let's find out. Well, here we have a definition of what let me put it over here, of what a wave function is. It says wave function may be taken to be the position coordinates of the particles over position space. The momenta of all the particles over momentum space. Okay, and there you see definition of momentum space is the set of all momentum vectors. Vectors is motion. P, a physical system can have. Okay, the momentum vector of a particle corresponds to its motion. Motion, 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 motion. All these people are talking about motion. So the only issue that we have to resolve for the purposes of physics is whether this boso, this Bose-Einstein, Bose-Eini, I like to get a boso-Eini condensate, that's good. Whether that is a solid or whether it's a wave. If it's a wave, it's not a state because it's not a solid, a liquid, or a gas. If it's a solid, it would just fall under solids. And so in that case, there's still one of the three states of matter. So I'm not sure what this fifth state is. No such thing as a fifth state of matter. Okay, here's the Bose-Einstein condensate according to the Wikipedia. This is what it looks like. Okay, and this they go through this and they say, well, let's wait till it starts again. So GIF here. In a gas, each atom has its own energy and is able to move freely, okay? When the gas is cooled down, the atoms slow down and their energies decrease. That's it. All you're doing is cooling a bunch of atoms, very low temperature. This is very low temperature. All the bosons are able to be the same energy in the same quantum state, okay? And they all form a single collective quantum wave called a Bose-Einstein condensate. That's it. So now the question is, are you staring at a wave or are you staring at a solid? Okay, let's look at it one more time. Here it goes. All these atoms, they're just going to freeze, get closer together, and they form this pancake, a wave, right? So it looks like it's moving. So if a condensate is a motion, that's one thing. If on the other hand, it's a, it's a still image, well, they have to tell us what it is, okay? It's up to the quantum folk to define what a condensate is. Is it a wave? Is it a solid? Is it in motion or not? If it's standing still, it belongs to solids. And if it's a wave that's moving, well, it ain't a liquid or a gas because liquids don't move until they do. Okay? Gases don't move until they do. You don't need motion in gases, liquids, or solids to define the category. Okay? When you look at milk on the floor, you say that's a liquid. Is it moving? No, not yet. But you can have it moving if you want, right? Okay, so here's the issues. Is either the Bose-Eini condensate, is it a solid or is it a wave? Is it something in motion or is it something that is standing still? If it's standing still, well, it would look pretty much like a solid. That's all it is. Okay, but if it's a wave of some kind, well, it does not qualify as a state. Therefore, it's not the fifth state or the sixth state or the seventh state of matter. Okay, turns out that there are more categories. This fellow said there's only 5 states of matter. Here's the Wikipedia. It mentions all these states of matter that the quantum folk found. They created all these categories just to complicate themselves. And all of these have nothing to do with science. They only have to do with technology. And people don't know the difference between science and technology. These people are simply seeing something in the lab which they cannot explain. They don't care about explaining it. They just give names to different phenomena, and then they put it out there and say, oh, we found this new phenomenon. And the only question anybody asks is, what can we use it for? How can I make money with it? And I'm going to look at this one for ionic condensate, okay? And let's look at this one. Give me a second here. What is this? Well, oh, Jesus. Give me a second. Get it smaller. One more. Move myself. Talking about moving me. Okay, here we go. A little more. Okay, sorry about that. Anyways, this is from, I think the Wikipedia says, a fermionic condensate or Fermi-Dirac condensate is a superfluid phase, 2 frames of the Universal movie, formed formed, verb, by fermionic particles at low temperatures. Temperatures is a phenomenon. No such thing as a photograph of temperature. Superfluid, what is it? Fluid with zero viscosity. And here we have, somewhere here, I think I have it. Is it this one? No. Okay, anyways, I was going to show viscosity, but somehow I lost it. Okay, anyways, viscosity simply has got to do with how much friction there is with the environment, whatever's around it. But anyways, it flows without any loss of what? Kinetic energy. That means you're talking about something that flows when we're talking about fermionic condensate. And superfluid, again, vortices continue to what? Rotate indefinitely. So this is a fluid of some kind, okay? But if it's a fluid, it's not a state. So they say this is the sixth state of matter. No, it ain't. It ain't because it's not a state. Okay, so yeah, we've got a little bit of problems with this. It doesn't fall under the category. So neither plasma, the Bose-Einstein condensate, or the Fermi-Dirac condensate, none of these are states. Okay, they're not states. And so again, here I show this. The fermionic Fermi-Dirac condensate is nothing but a cold liquid. They freeze the liquid, but it, you know, the atoms, but it has this ability to flow like a liquid without losing any energy. That's the phenomenon they discovered. Great for technology, has no purpose whatsoever in science. We cannot explain anything with this. We cannot explain how the universe works with this. In other words, you would have to, the other way around, you would have to explain why this is the case. What causes that to happen? Okay, and of course they don't know because they use words like frequency that they don't understand, all concepts, so mathematical concept, field, and so on. So yeah, they cannot explain the cause of why this is so. And they don't care. What they do is they just see some phenomenon in the lab, like in the 19th century, they saw electricity and they say, oh, we can use this. Yeah, that's technology. It's got nothing to do with science. You cannot use electricity, the word electricity, to explain something. What you need to do is explain electricity. How does that phenomenon happen? Is it the flow of little electron beads from atom to atom, like some bozos say out there? The bozos who came up with this nonsense, they keep believing that it's the flow of electron beads from atom to atom. That's the explanation we have today of electricity. Okay, so what are some of the conclusions? We can say that there are three states of matter. That's all there is, okay? Solid, liquid, gas. We're done. That's it. You can take a picture of any of those. You can take a snapshot of a solid, of a liquid, or of a gas. Okay? Stop. Period. We're done. Bose-Einstein condensate is either a solid or a wave. If it's a solid, it falls under solids. It's not a fourth state, it's the first state, you can say, if solid is the first state. If it's a wave, it ain't any of them. It's not a state. Period. Fermi-Dirac condensate, same thing. It's a cold liquid. If it flows, we don't care because it's not a state. And before it flows, you can say, well, we got something there. Well, I don't know what you got. What do you have? You have a liquid? Do you have a solid? Is it in gaseous form? You tell us. And whichever one you choose, you're just going to put them under one of those three categories. If it starts flowing, and the flowing is the condensate, it's the Fermi-Dirac condensate, it's not a state. Okay? Plasma is not a state. Okay? State is one frame of the universal movie. Motion requires two or more than one. Okay, plasma is a process, and there you can see that you can take a picture of a chair, any liquid on the floor, you know, puddle, any gas, you can take a snapshot out there in space if necessary. Those you can take a snapshots of because the words do not embody motion. It's a single frame of the universal movie. On the other hand, plasma, you require at least two frames of movie because plasma embodies the word ionization in it. Plasma is defined as ionized gas. You need to do something to the gas, so the history is included within plasma.